Okay, this is Dr. Mark Miney, and I'm just testing to see how this works and see if it will suit my needs. So, the biomimetic carboxysome project. I'm Dr. Mark Miney, and I'm the team leader, and I have extensive experience in molecular biology and bioinformatics, lots of hands-on experience in molecular cloning and protein isolation. I also have a team consisting of Scott Mason, a biomaterials engineer, and Mike Robinson, who's an experienced hand at entrepreneurial setting up of startup companies. Our plan is to mimic the carboxysome, which is the primary organelle of photosynthesis in cyanobacteria, which are the predominant photosynthetic organisms on Earth and the predominant means of sequestering carbon dioxide from the atmosphere and feeding it into the photosynthetic process to produce glucose. Our plan is to take an already existent CO2 harvester that we've developed that literally sucks CO2 out of ambient air and then repumps it into a system where we can contain it, mix it with hydrogen, and then add it to any kind of bioreactor or reaction chamber to convert the CO2 into a variety of products or feed organisms or what have you. Our plan is to take the CO2 generated electronically by our CO2 harvester to feed it to an enzyme cofactor embedded hydrogel cube. The cube will have artificial proteins, peptides, that mimic the photosynthetic process that leads to glucose production, and will also have an embedded color indicator indicating glucose levels. As the enzymes and cofactors process the CO2 into glucose, our sugar cube will turn an appropriate color of red, and then once it's maxed out in production, it can be removed and then placed in the bioreactor, which contains microorganisms that are engineered to make whatever substances you desire. We are uniquely qualified to develop this technology, and in Seattle we have access to corporations that specialize in this that we can help work with and possibly contract some of the work with. And of course, we've been successful in building the CO2 harvester in less than 1 year on a Amazon Catalyst grant and have a patent pending on the device. So we anticipate being able to develop a prototype of this biomimetic carboxysome within a year of receiving our NASA grant. So thanks, and we look forward to the competition and hopefully winning.